function f is continuous on the interval 0 to 6 and has values as shown in the table above. Using the intervals 0 to 2, 2 to 4, and 4 to 6, what is the approximation of the definite integral from 0 to 6 of f of x with respect to x obtained from a midpoint Riemann sum? So first thing that sticks out to me is that this is a midpoint Riemann sum. The next thing that sticks out to me is they give me the intervals in which I'm going to use to create my rectangles. 0 to 2 is the first one, so let's just get started on this interval from 0 to 2. So always, we're looking at the formula. If it's a midpoint left or right Riemann sum, we're looking at the formula base times height. Your base is going to be determined by the distance between your x values in the table. So since 0 and 2 are my x values, my base is going to be length 2. Now, the height is where you're looking at what kind of Riemann sum that you have. So since this is a midpoint Riemann sum, I'm going to be looking at the midpoint between 0 and 2 to determine the height of the rectangle. Now, in this table, you can see we have our midpoint, which is 1. The exact midpoint between 0 and 2 is 1, right? So the height of this rectangle is going to be 5. So the first rectangle for my Riemann sum that comes from the interval 0 to 2 is 10. So let's move to the next one. Now we're looking at the interval 2 to 4, circling that in my table. We know that that first one was 10, and we've got to find this next one. So we're working with base times height. You always find your base by the distance between your x values. It looks like our distance is still 2, so our base is still 2. And the height comes from the midpoint, since this is a midpoint Riemann sum. So the f of 3, well, the midpoint is 3. And f of 3 is -1, so that means my height is going to be -1. So my first rectangle has an area of 10, and my second rectangle has an area of -2, so it must be underneath the x-axis, right, because it's negative. And we have one more. I'm going to let you finish this last one in class.